Hello, YouTubers. Welcome to my show, Science Thursday. In today's episode, we're going to talk about electric cars. So let's dive right into it. Well, first we have to understand what we are talking about because electric we have been using for locomotion before petrol. So what we are talking about it right now. So we are talking about something that is street legal. That is very important because many people, even who are competent with electronics to basic level, they can build an electric car without any issue. But it has to be street legal. That's a difficult thing. On top of that, it must be designed for day-to-day use, not some track using or like once in a while. Day-to-day use for common people. That's the whole point. What do I mean by common people? As in the price bracket should be much closer to the ground, basically closer to zero rather than 2 million. So that's what we are talking about here. So how does this quote unquote electric car works? Well, they have four core components that you have to understand. First, there is a purpose-built chassis. Now, chassis, you can understand that a car is meaningless without a chassis. So chassis on an electric car is built from ground up completely different. They may look similar from outside, but they are built differently because batteries are not only heavy, they are also a very dangerous component because if you are not designing it carefully, if you are not containing them carefully, they can become a fire hazard if something punches them. So you have to design the chassis around the battery rather than the other way around. So that's why most of the batteries are generally placed into the lower half of the car. There are benefits of that because if you are designing a chassis from ground up and you have the luxury of battery, because batteries are built in blocks, so you can arrange them however way you want it. So that way you can get very high security rating, aka 5-star rating, which Tesla have that, Audi have that, Mercedes have that. Like you can easily achieve 5-star rating, which simply means no matter the accident at whatever the speed, unless you are talking about 500 km per hour. I'm talking about like in a regional basically autobahn kind of scenario where everybody is going like 200 kmph higher than that, and then an accident happens, there is a very good chance you're gonna walk out alive in one piece, hopefully. So that kind of safety happens because of the chassis is being rebuilt from ground up, and not to mention more newer technologies are used to build it and better designs because we have learned a lot. We have been building car for 100 years. So that's the purpose built chassis. Everything is built around it. Then we come to the battery bank, the heart of the system basically, because you have to understand electric cars were there before a petrol car, and they were much more popular, useful everywhere, simply because back in those days petrol pumps were not everywhere. However, electricity was everywhere. So what happened, because they were using lead acid batteries, which are like 3 times heavier and like 3 times less powerful, they simply did not have range. The best case scenario you could have expected was like around 30-kilometer range. So range was kind of limited. However, in those days town itself was very small, so that was not too big of an issue. But you can understand that petrol, they really took over because they could just add a big basically tank and be like, okay, it takes it takes like 100 km away is the fuel pump, so give a tank that has 200-kilometer capacity. So you get the idea. However, lithium solved that issue. As of now, lithium is quite good, and with modern technology, lithium still has some room of improvement left. Not in terms of energy density, but in terms of everything else, it can be improved. Like the amount of power, the amount of kilowatt that you can have per liter, it's kind of limited. You cannot push it too much. However, you can push every other thing. Basically, how quickly you can charge. If you mix graphene to its basically anode or cathode, done properly, you can turbocharge that puppy in like few minutes. Basically, you can charge it as quickly as a petrol tank, even faster practically speaking, and that technology Samsung is working on, and other companies have already started to work on that. Then there is changing the material from cobalt to basically iron, things of that nature. So there are many technologies that will make these better, but do not expect like your electric car to randomly go from 100-kilometer range to 600-kilometer range. We will get improvement, but it will be in percentage. However, we will get a lot of improvement in the upcoming year in terms of safety. Basically, if something punches it, it will not catch on fire because lithium fire is near impossible to put out. So you have to understand, like, and when you are talking about hundreds of these fighters have to be trained differently. So lithium is injected new life into electric cars and becoming more popular. Then we talk with the heart of the electric car. It's not the motor, it's the inverter system. Basically, batteries are generally DC. Your inverter, basically your motors are generally AC. So you need something to convert it. Now this is the research and development money where it goes. Basically, motor design, not too much changes. Battery design, not too much changes. Again, management, little bit chemistry here and there. Motor, like you can have a Hall-Beck array in terms of magnet to boost its power. Not too much goes on. However, every Tom, Dick and Harry knows the importance of inverter system here. This is what controls it. Basically, if this is good, your car could gonna feel like a supercar. If this is bad, it's gonna feel like a auto rickshaw, so to say. So this is the money shot, and it generally have whole list of technology from basically regenerative braking to VFD, basically variable frequency drive, then direct traction control or torque control. So it has all the technology that you even think about. It's generally coming from here. That's the main important heart of the system. Now, first we have to compare it to the most closest component because it lost in the past. So what will happen this time? Well, you have to understand that petrol, while ludicrously energy dense in terms of like, okay, this is oil, you burn it, what kind of energy you get out of it, it's awesome. It's higher than RDX. The only benefit RDX has is RDX does not need oxygen. The petrol requires oxygen from the atmosphere. So it's ludicrously powerful. There is no denying it. However, the engine that converts that power into rotational motion, it's inefficient as hell. Older ones were barely 10% efficient. Modern ones are 20%. Specialist built car can reach 30 to 40%. So 40 is like some luxury piece car that rarely reaches that. It's like 40 on lap testing in this scenario. Practically speaking, 30% below. Like 99% of the time you are below 30%, or if you are in a traffic scenario, 10%. So compare that to electric motor. In worst case scenario where your inverter is not that efficient, where your motor is overheated, in worst case scenario you are talking about 90% efficiency. So even though like let's say Tesla cars are heavier than petrol counterpart, they have same range. Now what do I mean by same range? Basically full charge. Both will give you 300. Only difference would be you can charge a petrol car very quickly. Just done, charge, no problem with that. So how the heck that's possible? Simply because of that, because petrol, while it has a lot of energy, you are simply wasting most of it away. In electric car, even though you are your energy source is less, like basically energy tank is less, you can utilize it much more effectively. So efficiency wise, that changes everything flat out. It's not like 10% better. It's like I'm at 90%, you are barely touching 20-30% in real day-to-day uses. So that's the biggest advantage. On top of that, in terms of moving parts, how many moving parts you have? Moving parts are the enemy of reliability. You want to make something, you want to reduce the number of components. That's the only way to make something last forever. Basically, you want to have something like have motor, because it has no moving part other than bearing itself, and bearing, if done correctly, if built to the specification and sealed properly, is gonna last forever, so to say. So in motor, you barely have 10-20 parts that are moving. When you're talking about internal combustion engine, it has 100 to 600 to 10,000 parts. And I'm not joking. Like when you're talking about supercars, they have like turbocharger, they have multiple turbocharger, multiple fuel injections also, multiple valve and multiple valve timing crankshaft system. So hundreds of parts. Now what does that mean? That simply means everything wears out. So you have to understand that half of the engineering is getting the performance out of a petrol, another half is making sure the engine does not explode on its own. So we have to have engine fuel pump system, engine cooling system, hundreds of things just to maintain this puppy. Not to get the power out, just to maintain this so it does not self-destruct. That also reduces the efficiency. So that is why like you have oil, and oil has to be lubricated continuously, like every 3,000 kilometers or 5,000 depending on your car and manufacturing and all that. So you understand, like that's a consumable. Like in terms of oil change on a electric car, that's like, yeah, change it once in a while, every 50,000 kilometers, simply because again dust and grime will get there, but it's not a consumable. Then we come to the noise aspect, because it is explosion. Whenever you are talking about a 4-stroke engine, there is an explosion stage, basically where you compress it, fuel is mixed, and then spark plug, kaboom. So that's one explosion. Here's the deal. When you are talking about RPM, generally that means that many kabooms are happening every time in every cylinder. And your car could have like 3-cylinder, 4-cylinder, 18-cylinder. So again, mini explosion, hundreds of them happening all the time. That's where most of your energy is going, because even though you can suppress the sound, that simply means you are converting sound energy into basically heat energy. You are still wasting energy. That is the reason that low efficiency is there. Most of the energy is just wasted in terms of basically noise, vibration. Now vibration is the reason why modern cars don't last very long, because to achieve high efficiency, basically mileage, basically gallon per kilometer or something like that, they're like, okay, make it light. Awesome. Here's the deal. No matter how good your metal is, be it titanium, be it tungsten, whatever it is, if you keep shaking it, it's gonna break. Like nothing can stop against that. But your engine is gonna vibrate like there is no tomorrow, because again, inherently it's trying to convert this into this. So it's inherently far more vibration rich, so to say, and it destroys everything. Basically, your car fatigues because of these puppy. So you can understand that flat out, there is no comparison here. And then we come to the emission aspect, because there are many people who don't believe in global warming and all that. However, even those people are like, hey, I don't want sulfur in my air, I don't want lead in my air. Even those people know the fact that these puppies are emission. emission kings. Basically, they pollute. Pollution wise, nobody has any second chance. Like, yeah, we have to stop pollution. China knows that. So you have to understand that that is another aspect. And most of the part is that even though your car is like, barely moving in a traffic, it's mostly just acting as a heating element and multi-megawatt heating element if you have a like large traffic jam. So how does it feel to drive? Now, this is the primary reason where early electric cars failed and Tesla created such a ruckus, because you have to understand this. Electric cars, basically, scratch that. Cars itself is a part of our ego. Basically, it's not something that you like, it's a tool you buy and you replace. It's a part of your ego. You want to show mine is bigger. Mine is bigger than yours, bro. Like, it has to be that. Like, that was the biggest flaw with early electric cars. Basically, most electric cars were made so conservatively, so cheaply that they were like, I don't want to drive that. Like, hey, it makes my look small. So, it makes you feel small. So people don't want that. Now, here comes that guy Tesla. Again, he could not deliver the car on time. Again, to be fair, that he still cannot do that. Deliver the cars on time. But like, again, the car, the moment you sit on, it's like, damn. It's like somebody took time to build it. It's fast. It's loud. It's like, I know what I'm doing kind of car. So it was a supercar. So nowadays people understood this aspect. It's like, hey, car is a part of our ego. It must look damn good. So that what started the resurgence. On top of that, driving on an electric car is better than anything comparable, flat out. There is no comparison to that. And it's super fast. Now, to give you a context of super fast, there was an electric bike that was built as a demonstration of battery technology. It had 0 to 60 under a second. Like, basically 0 to 60 miles per hour under a second. And the reason why it was limited to that under a second, because if they push higher than that, the person will go blind because the retina will fall apart. Like, it was multi-G acceleration capable. So you have to understand that if you want power, electric motor is like, bro, I got this. Think of it this way. You see diesel locomotive, most of them are being moved by tiny motors. Like, these motors are like 1000 horsepower each. So in terms of power, in terms of oomph, in terms of RPM, and in terms of torque, they're like, bro, I got this. Basically, the limiting factor when you're talking about electric motor is generally how you're gonna feed the power. Nowadays, that is also not an issue. Is there like, can your tire grip the road at that speed? Most tires can't. Basically, I provided the video down below. You can see that, and tires start to spin out because it's so much torque there. So you have to understand, you will never feel like, hey, it does not have enough power. It's like, I got more than enough. I got more than enough. Like, I got dangerous amount of acceleration. So, and the interesting part of basically electric motor and the death nail to internal combustion engine is basically internal combustion engine has a maximum torque at 1 rpm. So you may have a basically engine that has like large rpm range, where it's like 0 rpm to 9000 rpm, but it will give most of its power most generally around 5000 if it's not turbocharged. Problem with that is basically if you are in first gear, your car starts to like freak out. Basically the rpm goes too low for slow speed and you cannot do that. So because then you have to do clutch brake. It destroys your clutch. Or if you are smart and your traffic is mostly crawling, you bought a basically torque converter, automatic torque. So torque converter does allow your engine RPM to go down where the torque is way too less, because it could choke out. If you do that directly without clutch, can choke it out. The torque converter improves the torque by 8 times or 20 times. Then you get can crawl. Electric motor is like, bro, I have 100% torque at 1 RPM. And I can have that RPM, RPM into 1 hertz. Basically, it can be like your wheel is moving like this, and your electric motor is like, I got the torque, bro. I will not slip back. That's the reason why electric trains can start at all. So that is the whole point. You can control torque. Now again, there are many complicated ways of controlling it. Generally, you can just increase the voltage. Basically, you have a motor that's rated for 300 volts. You don't need torque. Basically, you are driving, everything is calm, everything. You reduce the voltage to 100 volt. Your torque changes. And if you're like, hey, I have to drive on peaks, make it to 300 volt. That's how you can control the torque, and there are many other ways also. So that's one way. Then you talk about the RPM. Basically, how you're going to control the RPM, that you control by frequency. Higher the frequency, higher the RPM you get. So you can understand this part, that we have two independent control on one device. That's amazing. Like, that's the another amazing part. Like, whoever drives the electric car is like, this is horrifyingly fast and quick, because both of the aspect, because like if you are accelerating, it can detect that you are accelerating. It will not improve the frequency, it will improve the torque, basically improve the voltage, because it knows you need torque right now. Once it changes that, it can automatically change. So basically it's a magic transmission that is doing everything. And to change the rotation, you just change the polarity. So quite amazing, flat out quite amazing. So why are we not seeing it everywhere? Well, first you have to understand we already started to see this everywhere. The change takes time. This is one of the crucial aspects. Maybe one like is the oil company is like big government. No, none of that. It just takes time. We had electric system, then we went to petrol system. Petrol took hundreds of years to get here. Basically, think of it this way: if you are talking about some company, how long it takes for a company to become well known, to be a point where they're like, I have service center every city center. I have a service center in every Tom, Dick, and Harry place. Like it takes time. How long it took for petrol pumps to sprout everywhere? It takes time. Like you are talking about something that it takes time. Is expecting that to happen like overnight? That's not gonna happen. It's gonna take time. Then you have to understand this aspect, which I'm very proud of, is that small scale change has already begun. In India, these electric scooters have already made a comeback. Now, the reason why I'm saying comeback because they came very early on also. I was in standard 10, but that time they had lead acid battery. So they did not last it very long. So that was like, they died out. Now they are making a comeback with lithium ion batteries, and they are like, quite popular nowadays. And even in small town in India, you can see these electric rickshaws, so to say, and they are replacing autos. Why? Because autos require fuel. Fuel is getting expensive per year. It's getting more and more expensive, so these are becoming more and more economical. So right now on small scale, more and more people are changing right now. It's not something though that will happen. It's like it's already begun. The change has already begun in my own hometown. Like I have like 5,000 of these things. So, and there are other big cities also. They are like people are using this. So change has already started to happen. Now, what will that mean? That simply means the whole pipeline of manufacturing the battery, manufacturing the motor, manufacturing the inverter is reaching mass production. Right now, we are not there yet. You might think, oh, Tesla is mass production. Yes and no, because quote unquote, you can say mass production. The moment anything reaches 100,000, you can classify as mass production. But other car companies, 100,000 for them is like yeah, we had a one flop model that we only made 100,000. So you have to understand, we have to like one more zero to add to that we have to add, then we can say yeah, we are truly at mass production. Because you have to understand there is a whole supply chain of a car system that you see. Basically, if something breaks, where are you gonna replace it, where are you gonna repair it? Everything has to be there before you can expect like, oh, electric car will replace ICE cars. Right now it's not gonna happen. So what kind of time frame we are talking about? Well, we are talking about 2040, because China has already taken some very big steps, very big steps. Basically, as early as 2014, they're like our all same way India had a lot of pollution in Delhi, and they decided, okay, all public transport have to go to CNG to reduce control the emissions. They got that, they successfully did that. China did something similar in 2014. They're like, okay, all public transport have to change to electric. Sooner or later, they have to change it. And they, instead of applying this nationwide, they are like, okay, each big city has to do it first, then they're gonna learn from that, like what happened, what helped us, what was wrong, then they're gonna improve that. So as of now, they have like already 2-3 cities that are on that list that have 100% of city owned basically quote unquote taxis, not Uber and all that. Quote unquote taxis are 100% electric, 100% electric bus. So they have reached that, like they have already reached that, and benefit of that allows them to standardize the supercharger architecture, figure out like what works, what does not work, and the whole supply chain is there. Basically, oh, if something breaks, how you're gonna fix it? Because again, there are fewer parts in electric car, but again, there are still parts. You have to still repair it. So changes has already begun, more. And taxis is a very good thing, because taxis do not travel that much. Basically, if I'm talking about normal average taxi, they are generally at 100 kilometers. So you're gonna put a battery bank that is like 150 kilometer capable. You're not gonna put 300 capable, simply because you don't want that. Because the higher the battery bank, the heavier it becomes. The heavier it becomes, the lower efficiency you get per kilometer. Basically, your mileage goes down. So change is happening, flat out. Change is sorry about that. So change is happening, but it will take time. So I can easily expect by 2040, 20% of the cars will be electric cars by that point. And if price hike on petrol happens much more drastically, more and more people will buy that. So this was my presentation on electric cars. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. And please, if you didn't like it, I would urge you to press dislike, press it twice to show me your disappointment. And please leave a comment, because I reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.